Us.
No.
Just kidding.
Incorrect.
Just kidding. Probability is the worst part of math. Okay, but geometric probability, not too terrible, okay? Some of the questions on the board are a little challenging, but that's because I want you to have those, like, when y'all are working together, I want y'all to be working through those, like, a little bit more challenging problems. But when we get to, like, test and quiz and all, no, sorry, we're not having a test over this unit. We're just having a quiz. But when we do our quiz, we're just going to, like, kind of be a little bit more basic. But if you remember from probability, the way that we write our answers out are in fractions, okay? So the way that we answer probability questions is we set them up in fractions. Usually we set this up in part over whole, okay? Part over whole. That's one way you can do it. We also talked about how it would be like favorable outcome. Favorable over all possible outcomes or all possible ways. Okay. Favorable, all possible, part over whole. And then we also have specifically for geometry, when we're doing like area and all that kind of stuff, a lot of times what you're going to look at is you're going to do like your shaded area, because that's the area that we care about, over total area. Okay, so these are just a couple of the ways that you might see the answers that, like, that's how they need to be set up. So just kind of like keep that in the back of your mind as you're working through some of these problems. I'm going to give you a little example because there's only one that, like, y'all probably have never seen before, and it's a little harder to kind of look at because of the notation. But an example of geometric probability is when we have a line. So let's say that we have line AC. That's your whole line. But somewhere on here we have a point B. So how many segments do we have of that line?
Oh, 3, 2.
We have 2 segments of the whole, like 2 pieces of that whole line. Okay? Well, then they might tell you, hey, AC is 20 centimeters. BC is 5 centimeters. And then they'll ask you, okay, find the probability that if you were to find point X, that point X is on AB. Okay, so this we might do, hold on, favorable over possible, okay? So when we say favorable, that means that's what we're looking for. So what are we looking for? AB. That X is on AB. So when we do favorable over possible or part over whole, what is the length of AB? 15, because that is your, like, the rest of the line. 15 and 5 make 20. So it would be 15 over 20 because that's your whole. And then we simplify. 3 over 4. Okay, the last thing I want to talk about before we get to the board work is kind of talking about, going back to what we talked about yesterday. We talked about area of a circle yesterday. Guys, if I'm looking for area of a circle, that means I'm looking for the inside of it, like the space that it takes up. That's what area is. What is circumference? It's the length around, okay? So think about if you're trying to find the area of a square versus the perimeter. The perimeter is going, oh, if I were to build a fence around this square, how much fencing would I need? But area is like, how much grass does this cover? That type of thing. So area versus perimeter. A lot of people are trying to use circumference today as they're working out these problems. It's not circumference. When we are working these out, we need to be using area. Now, area of a circle is pi r squared. Let's say that the area, the radius of this circle right here is 10. Okay? When you're finding the area of these circles or finding the area and stuff, I do not want you to get this long decimal. For the problems we're doing specifically, when it comes to geometric probability, we need to keep it simple. So instead of doing all of this, we're going to say, okay, this is pi 10 squared, or the area is 100 pi. Keep pi in the answer, okay? Because then when we're doing our fractions and we're doing that all of the probability stuff, we can simplify this 100 if we need to. Does that make sense?
Yes, ma'am.
Okay? So whenever you're doing area of a circle or anything like that, I want you to keep it in terms of pi. If y'all remember, that's what we learned last unit. Okay. So, what we're probably going to do is I'm going to give y'all some time to work through the board problems. And then after that, I'm going to check homework and all that.